Okay, so there we are. Welcome to another Microsoft Excel Toronto Meetup group. And we are in July. This will be our last session before going for a summer break during the month of August. We'll tell you more about that in just a minute. Everyone, welcome. We have Melissa de Korte today. I will introduce her after a couple of announcements and notes I would like to give you. So you know the drill. We are using Teams. If any problem happens, just feel free to drop the connection and come back. It should work to solve any issues, hopefully. Feel free to leave your comments and questions in the chat. We will be recording the session and then we will upload the recording in a couple of days, usually around the weekend, to our YouTube channel. That it's now close to 2,000 subscribers, I think it is. And in there, you can find all the recordings from all the sessions we have ran since the pandemic times. Before that, we started in 2019. For those of you who are new here, we were meeting locally in person here in Toronto, and then we moved to online, and we have stayed like that because it allows for more people to attend our sessions and also for us to get to have people from all over the world to present. So they don't have to be in person in Toronto. It makes everything much easier for us to share knowledge, to connect with each other. So welcome everyone, and that's pretty much how this is working for those of you who are new. If you register for a session saying, responding that yes, you will be attending the session, you become eligible to receive an email after the session, a couple of days after, where I will send you the recording for the session, the link for the video recording, any files that the presenter may be sharing, and also more information I may have around this time about Excel events or books or any novelties about Excel in the moment. So it's good to register even if you cannot attend in person, then you can receive all this extra information. My name, for those of you who don't know me, my name is Celia Alves. I am the founder of the Meetup group. And since the first time, Grania Duggan has joined the sessions from the very first session we ran back in 2019. I work as a senior business analyst. I've been working as a consultant for a couple of years before that, as an Excel consultant. So I develop solutions in Excel to help companies automate their tasks, save time, save money. And I became a Microsoft MVP in 2020. So this year, my award was renewed for the 5th time, which is incredible. The opportunity to connect with the other MVPs and the Microsoft Excel team and have access to what's going on with the product that this meetup is all about. Grania, do you want to say something? You're hidden. Nobody sees you. Oh, no, not true. You have your camera there. Sorry.
Yeah, no, I just have been enjoying these sessions for, what is it, 5 full years now? And the first year in person was quite different, but we get much, many more people are able to attend when we're virtual. So the advantage of virtual is that we're meeting people from around the world, where when it was just in Toronto, it was very intimate, but it was small. So it's there's advantages for both. So I've really enjoyed both versions. So thank you for letting me be such a big part of it as the years went by.
Thank you for all the work that you've been doing. So one of the things that Grania always does is she goes after the session, she watches the presentation again and writes down the chapters, the timestamps on where each topic starts during the recording, and then we can have that on our YouTube channel to help people every time we remember something. Oh, I remember I have heard about this on this session. We can go back and quickly find what you need, or at least quicker than it would be if we didn't have those chapters. So it has been helpful for me a couple of times, and it's a great work. Thank you. So what else? Next session will be in September. So like I mentioned, in August, we are not doing any event. Usually we do once a month. Exceptionally, this month of July, we ran 2 sessions. This is the second session. And we will have George Mount, who also is a Microsoft Excel MVP, presenting about Monte Carlo methods with Python in Excel. He wrote a book about analytics in Excel with Python, and so he will be sharing a little bit of what he has shared with us in that book. Women in Excel is a group on LinkedIn dedicated to women in Excel, and Grania is one of the founders. So again, Grania, if you want to just quickly tell people how they can join and what's the purpose of the group.
It's Women in Excel is a private LinkedIn group for women. So gentlemen, we ask that you refrain from trying to join women. Please, we would love to have you join the group. We started out with 3 of us, and now last time I checked, we were coming up on 190 members. I'm not quite sure what it is at the moment, but like it's really growing, and it's only been around for less than 6 months. And the value that we're getting is that women are asking questions, they're sharing their successes and their not so successes. For instance, we've shared Melissa's wonderful book, and people discussed what they got out of it or what questions that they ran into, and it's been absolutely marvelous. And we have a lot of very, very generous women who are members who find things on that other women have done and post to say this woman did this or that thing, or here's a great site for resources. So it is a wonderfully welcoming thing. Another thing that we've been doing, and we've just had one so far, and Melissa again was the guest on that one, and she did a presentation about Power Query M that I heard. I had to miss it. My son was moving that day, so I was missing it. But it was, I heard a really great session, so I'm really sorry I missed it. But there'll be more. The next one that is scheduled so far is in September, and I think there may be more than one in September. We haven't got things definite yet. So please, I will put the link in the chat in just a moment, and please feel free to join us. It doesn't matter how experienced you are. Anyway, that's enough
yeah,
from me.
Great. Yes, it's been great to be there in the group as well. So feel free to join us. Okay, so Excel events. At the moment, we have the Active Cell, which is an event organized by the same organization that organized the Financial Modeling World Cup. And at the end, the Active Cell event happens in Las Vegas in December. It will have a component of training sessions, conferences, and then the last day will be about the finals of the Excel World Cup, the Excel Championship. So it's always exciting to watch the competitions. It's running throughout the year. There's different ways of joining and participating, and then the ones who get selected to the final will be competing there in person. If you want to get 10% off, if you are considering joining, you can get 10% off with that link in the QR code there. Feel free to check. We will also be posting in the chat. And if you are really considering, I suggest you register as soon as possible because the tickets increase price, I think, every month or so. And then you will also receive on the email that we send after the session, we will send an email with any materials we have to share. These slides are part of it. You will have the opportunity to explore all these links, our YouTube channel, my YouTube channel, my blog, suggestions of Excel books. So feel free to check these out. And also my newsletter, who goes out once a month with information about anything that is new in Excel. The Microsoft team is always improving or adding new features, and I follow those and compile those to send that information to you. My training program about automation of Excel reports or Excel reporting procedures, I would say. It's the Excel Snap Reports training program. Feel free to check that out as well. It has a couple of free modules available. And then if you are interested, you can buy the course and join from there. And enough of that talk, because now we need to present Melissa. And there's the book that Melissa wrote together with Gregory Deckler and Rick de Groot. Melissa de Korte is a passionate problem solver known by her ability to simplify complex problems with Power Query and M. With an impressive track record as an enterprise DNA expert and Fabric community super user, Melissa has become an asset to the data community, actively engaging, supporting, and inspiring others. She posts regularly on LinkedIn using the hashtag PQ Today's Menu, so PQ for Power Query, hashtag PQ Today's Menu altogether. If you look for that hashtag, you will find Melissa's postings. And she is the co-author of the Definitive Guide to Power Query M, the book that we are seeing on the slide. This book is a comprehensive resource essential for both beginners and seasoned professionals. There's my book here, my copy. And for all her contributions to the community, Melissa has been awarded Microsoft MVP just recently, which is great news for all of us to have her on the MVP side and have her contributions there as well. So if you are interested in the book, if you want to buy a physical copy, there's the two links there from Amazon or PAC, the publisher, from where you can purchase the book. We are also going to give away 3 digital copies today at the end of the session. Grania, do you have the link for the form there? I think Grania has the link and she will post it in the chat.
Yes, I'm just posting it now.
Okay, great.
Posted.
So if you are interested in getting a digital copy, and by the way, if you have already a paper copy and you have the proof of your purchase, you can find the information, I think just about in the beginning, the first few pages of the book, where you can send your proof of purchase and get the for free, get the digital copy. If you do not have the book yet and you would like to have a digital copy and put in your name for the opportunity of getting one of these 3 giveaways, feel free to fill in the form, and we will be selecting 3 people at the end of the session. And the only thing we ask is that you are here at the end of the session to say, I'm here, and then I will send the information, your email and email address and your name to the publisher then they will send you the copy. If you are not here and you are picked up on our selection at the end, then we will find someone else to give the book. Okay, so that's it. Let's see, and I think that's all for now. There's the LinkedIn address where you can find Melissa de Korte and connect with her there. There's my contact information as well. If you want to connect on the social media with me, feel free to do so. And Melissa, I'm talking too much. I think it's now time for you to take the stage, fill in any blanks that I may have missed introducing you. Thank you for being awakened so late. I know it's what time is it? Like almost midnight for you?
It's 1:45.
Oh, wow. So we need to be grateful in double for Melissa for her being available to share with us this time today. And we are excited to learn about custom functions in Power Query. Melissa gave us a list of different topics, and this was by far the topic most chosen by people who answered that survey. Thank you, Melissa, and welcome.
Yes, thanks so much. I'll share my screen if that's okay.
Please. Yes, please.
There we go. Let me know if you can see that.
Yes, we can see it.
Perfect. Awesome. So here we go. First of all, welcome everyone. Today we are going to dive into custom functions and how these solutions, no matter how big or small, can impact the way that you work. So what can you expect? Well, we'll cover, of course, what custom functions are and why they are worth your time. We'll also cover essential theory. Trust me, it's easier than it sounds. And then we'll head over to the Power Query editor and we'll dissect some of my custom functions and touch on some considerations as well, because ultimately designing functions means also making choices. In the file, I will be sharing that at the end of the session. You'll find other ready-to-use examples and you can explore them on your own and try them out. All right. Quick about me, Celia covered almost everything, so we can be quick to move on here. So my name is Melissa. In my day job, I focus on digitization, automation, and of course, data analysis. I am an enterprise DNA expert, Fabric Community Super User, and MVP. And I do post on LinkedIn. As you can see there, PQ today's menu, that's the hashtag that I use. Feel free to connect with me in that space.
Melissa, sorry
Yes.
to interrupt you. Would you mind quickly explaining what enterprise DNA is so that people who may not know?
Yeah.
Okay, thank
Ent
you.
Enterprise DNA is a learning platform. It's called Enterprise DNA, and they have a forum. And people who provide support on that forum can be awarded the Enterprise DNA Expert Badge, which is similar to becoming a super user on the Microsoft Fabric community. So it's similar in that regard. Does that
Thank you.
clear it up? Awesome. All right. Finally, I am an author of The Definite Guide to Power Query M. That is a book that focuses on the M language, making it a perfect resource if you want to get more stuff done with Power Query. And already mentioned, there are 3 ebook copies up for grabs today, so who knows, you might be one of the lucky winners. Time will tell. Here we go. Time to get started. So what are custom functions and why should you care? Well, custom functions are user-defined functions that enable us to store specific routines. Functions can take none, one, or multiple parameters, but they will always return a single value. So the Power Query formula language, better known as M, comes with well over 800 functions. Yet you may find something's missing, or you notice that you're repeating a certain sequence of transformation steps over and over again. Well, in those cases, creating a custom function can be very practical. So benefits of custom functions extend beyond reusability alone. They also ensure consistency. So once developed and implemented, no matter how simple or complex that solution is, its logic will be applied in the exact same manner each time, leading to more predictable outcomes. So advantages of custom functions: accelerating query development, standardizing the applied logic, and of course you can share them with others. Time to address the theory, right? And learn how custom functions are created. Now, the theory itself isn't that hard. And once you've learned how to recognize the pattern, you will find that they're no longer as intimidating as they used to be. And we'll start with the most basic recipe. Here we go. So every custom function starts with a set of parentheses, those brackets right in front here. And then you see the goes to sign. That's the combination of the equals and greater than sign, which is always followed by a function body, represented here by those 3 dots. And that's it. That is the pattern. All custom functions consist out of these 3 building blocks: a set of parentheses, the goes to sign, and a function body. Think of it as the base layer of our cake. Once you have that foundation, you can start adding more complexity to it. or adding flavor, like a filling to a cake. And that's where parameters come in. So they enable us to pass something to our function. A parameter then acts as a placeholder for an input value, which can be referred to by its name from within the function body. So to make that more clear, here's an example. There's one parameter between the parentheses, and its name is input. Now, if you need more parameters, you would simply enter a comma and provide another name. Then we see the goes to sign, and we know that what follows it is the function body. This function contains an expression which also references the input, so the parameter by its name. Now, I don't think this code leaves much to the imagination, right? It combines a prefix called myPrefix_ to an input. But there's a catch, because what if that input isn't a text value? That could cause problems, right? So time to add frosting to our cake. So even though this function works, we can improve it, making it more reliable by being explicit about types. And here's what that looks like. So there's one parameter, because we're looking at the exact same expression, one parameter called input, and its argument is expected to be compatible to a type text. Between the closing parentheses and the goes to sign, the function output type is specified. Now, text combined will yield a text value, so we expect our function output value to be compatible to a type text as well. And finally, of course, you can add sprinkles, whipped cream, or whatever you like on top. Now, I compare that to adding function documentation. That is a topic of its own and not something that we'll be addressing today. So although some of the examples in the file will have documentation, we won't address that during this session. All right. So quick summary. What do you need to know about custom functions? All custom functions consist out of a set of parentheses, the goes to sign, and a function body. At its core, that's the most basic pattern, defining every custom function in the M language. Between the parentheses, you can specify parameters. And all parameters are required unless explicitly declared optional. And we'll see an example of that shortly. So when defining custom functions, it's a best practice, right, to specify types as well. And each argument value needs to be compatible to the corresponding parameter type. And the value produced by evaluating the function body needs to be compatible to the function's output or return value type. So any questions at this time?
No questions, but Eric Ohms says that custom functions are the lambdas of Power Query.
Yeah.
Okay. Okay, so it looks like that's the only one.
Perfect. Okay.
Oh, no, we have a new one. Why is text as text written twice?
Text as text. Well, you see that input here, that's a parameter that's specified to be compatible to type text. Then you have the closing parentheses and the goes to sign there. So in between here, you specify the function return value type. So that's why it says as text, as text. If you read over the closing parentheses.
Yeah, thank you.
Yeah. All right. There we go. So, as you can see, a lot of queries in this file, and we won't have time to explore them all. So, anyway, we will be dissecting some of these custom functions together, and the file will be provided to you so you can explore the others on your own. Now, should you have questions, just send me a DM on LinkedIn, and I'll try to help you out. Now, I think you can organize custom functions roughly into 3 specific groups. And the first group are functions that generate tables out of thin air, right? These functions are very useful when you build data models, for example, in Power Pivot or Power BI. They generate a table that most of the time, of course, is not available in any source system. And examples can range from simple supporting tables, like a refresh table or tables for binning and grouping, to more complex dimension tables. The best example of that is probably the date dimension, right? That needs to reflect business logic and business rules, which can make them a bit more intricate. So the query that I want to highlight from this group is the simple yet effective refresh table. It's straightforward and powerful. Here we go. So before we actually examine the code, I'm going to invoke this function. Now, we can already see in the formula bar the function initialization. So we see that this takes or at least this has an optional parameter, right? Let's invoke this. There we go. So it generates this invoked function query, and it outputs a table as the function return type that we saw a little earlier. Now, the best part of storing these types of tables in functions is that the output it generates is consistent. And that consistency makes it easy to append this refresh table to similar refresh tables from other data sources. So I created another one here. It's called refresh df invoices. Now let's imagine that I have a connection to a data flow and that contains invoice data, right? When I connected to that source, I also brought in that refresh table. So this table, right, I can combine the two because their layout, their format is consistent. Let's rename this. There we go. We see that an optional parameter, right, when it's not provided any value, that will be replaced by a null value. So we can also provide a name for our data source by inputting a string here. Let's call that model. There we go. So now I have two tables, one with the refresh information from my data flow, one for the model that I'm currently working on, and it's easy to append the two. Now, I know there's an append queries button here that works fine, but you can also use the ampersand, and that's the thing that I generally like to do. Let me just copy the name so I don't have any typos. Let's move back. There we go. I'll use the ampersand to combine the two tables. There we go. Awesome. So this allows us to provide accurate insight into the refresh status of all of the components within our data model. Let's take a look at the actual M code that we use to generate this table. So I'll open this refresh table function, and I'll zoom in so we can take a look at the code. So there are a couple of things that I would like to address. And the first thing is that we're looking at a let expression. Now, that is probably the most important construct within the M language. It enables us to generate a single expression that can be comprised out of multiple steps. So in M, a step is an identifier or a variable that stores the value assigned to it. For example, source on line 2, that has been assigned a function value. And we can tell because we already learned how to recognize its structure. We see a set of parentheses that may include parameters and their type, and there's one optional parameter there called source name. The argument value needs to be compatible to that of a type text. Next to that closing parentheses, we see the function return value type, which is specified as table. Then the goes to sign, followed by the function body, which contains a let expression. And we see several steps have been created. I can identify 2 different steps, and their variables are called now and last refresh. Now, each of these variables has been assigned an expression, and we can reuse those values by referring to their name. For example, now on line 4, that has been reused here on line 16, 18, and 19 as well. So last refresh is then referenced after the in clause, specifying its result as output for the function assigned to source, before source is returned as output for this query, returning a function value. So there are many use cases for custom tables, tables written in M code. The vast majority of them are highly specific to your business needs. However, what they all have in common is that the table itself is not available in any source system, and storing them in a function ensures that they can be deployed rapidly and consistently. All right, so what did this exploration teach us? Well, for starters, that you can create functions that require no user input at all. All parameters are required unless declared optional using the optional keyword. When an argument value is emitted, an optional parameter of is sorry, when an argument value is emitted for an optional parameter, a null value will be used instead. So most important of all, we've also seen the let expression. And that construct allows us to create a single, more complex expression in the M language. So every let expression starts with a let clause and ends with an in clause. And in between, you can create a comma delimited list of variables with expressions assigned to them. Those variables or steps store the value of the expression assigned to them, allowing that value to be reused or passed on by referring to its name. And finally, the result of a let expression is determined by whatever follows its in clause. All right, that was a lot of theory. Any questions on that?
Yes, we have Ahmed Koriayam says, can custom functions be used for an Excel database, or would they make more sense in the context of a financial model?
Right. I think custom functions have many applications. For an Excel database, I'm not quite sure what you mean by that. You're transforming data, you're preparing data within Power Query. That doesn't change. So I would say yes.
Yeah, I guess we need a little
unless
bit more
I get
context. Yeah.
Sorry?
I guess we would need a little bit more context to be able to answer. Is Ahmed meaning if this can be used to access an Excel database or to build an Excel database? Both can be answered yes, but maybe depending on, so we can use custom functions to import the data from an Excel file, for example. We can use them to then later in Power Pivot create a connection create multiple tables that can be related, and that way create a relational database. But anyways, just more context would be great for us to be able to answer that.
Yeah.
And we have another one from Varsham. It says, let's say we have a number of M functions which we want to use every time. We also want to avoid copy and paste each time. What is your preferred way of handling that?
That's an awesome question. Yeah, you could use a service, for example, GitHub, but that's not within the scope of today's session. Another approach would be creating a suitcase, and I did already prep an example of that here, where you create one query that stores code for multiple queries, multiple functions, and you can bring that suitcase along. So this contains the 3 functions that we see here in
That's awesome.
my group A. So you, instead of bringing multiple queries, you just bring one, and that contains the logic for whatever you build, whatever you're using or your team is using.
Another method I've been using, I don't know if you ever tried Monkey Tools, Melissa?
No.
Yeah, Monkey Tools is geared more towards Excel users, although it also has some functionality for Power BI users, and it allows us to store queries and also lambdas and other items, and then recall them from any other file and just inject them directly from into our Power Query editor. It's a great tool. I can put some information if someone about where to find this, if someone wants to look at that.
Awesome.
Thank you.
Perfect. No other questions? Right, then we'll move on. So the next group that I think is out there is functions designed to be applied to values in a table, a list, or a record. So that represents all of the solutions that bring you daily joy, I would say. So by far, most custom functions will be designed from that perspective. They will either answer a question or transform a value. So a very common question, at least one that I've encountered frequently, is how to calculate the difference in days between 2 dates, right? And as always, that depends on what you need to take into account. For example, do you want to include the end date as well? And do you want to exclude weekends, so a Saturday and a Sunday? Or maybe even exclude holidays or other days, whatever. So I've encountered this question so many times that I thought, well, why not build one solution that provides 6 different answers? Let's see what that looks like. So here's my date div calculation, and I'll open the advanced editor. I'll zoom in. Now, hopefully the first thing that stands out is there's an awful lot of code here to look at. But don't worry, we'll decipher it together. So we see that a function has been initialized, right? We see those parentheses, the goes to sign, everything is there. And this function takes 3 parameters, one of which is optional, but all of them are nullable. It's an important detail. So the from date is a nullable date, the to date is a nullable date, and an optional list dates to exclude is expected to be of a list type. Then the return value for this function is expected to be a record type. And the function body consists out of a conditional statement, right? We see the words if, then, else highlighted in blue on line, 4, 6, and 16. So the condition is specified within the in clause, right? On line 4. And it takes both the date inputs, so the from date and the to date, and it places them within a list. I can tell because I see the list initializers, that's a set of those curly brackets. They're placed around the values. Then any nulls are removed from that list before the list items are counted. So if less than 2 items remain, the difference between dates is impossible to calculate, right? We're missing a reference point. So in a case like that, the then clause will take effect, right? And a difference in days can't possibly be determined. So remember that our function return type is expected to be a record value. So here we see the record initializers. That's a set of those square brackets. And there's a field there for all of the outputs that I want to generate. And all of the outputs have been assigned a null value. So this record will return A record with 6 fields, and all of the field values will be null. So what if we are able to determine a difference in days, right? Then the else clause will take effect. We'll also take a look at that. You can probably already tell that this contains more than 6 fields. And that's because it contains helper fields that store values for intermediate calculations. And I'm using that because I want to reuse certain expressions over and over again within this record expression. Now, an example of that can be found on line 18, for example. So here we're calculating the date difference, including the end date, and that means that we're taking the date difference without the end date, which is here on line 26. It refers to this field name, and we see the expression that has been assigned to that field, right? So it just subtracts the two dates, or the end, the from date from the, right, well, it's late here. Anyway, we get the date difference between those two dates, and we are adding one back to include the end date for this calculation. So we're creating building blocks and we're reusing them within this record. Ultimately, I want to return a record that contains just those 6 fields. So I'm removing any helper fields that I've created along the way in the final cleanup here. All right, let's just see what this returns. I'll press done, and we'll take a look at our example here. And here we see that, let me move that to the side so we can see the full expression. We invoke that function, we inputted the start date, the end date, and we even provided a list with dates to exclude. Awesome. And we generated a record. So I'll press off to the side so we can take a peek. There it is. There are the values that have been returned by all of those calculations, right? And a user can now pick and choose what they need to extract from this record. So they would hit those sideward arrows, and they'll make a choice on what they require. For example, they'll give me everything, including the end date, but without Saturdays, Sundays, or holidays. And I'll click OK. So one function that is able to generate 6 different answers depending on what you're working on. But let's face it, users will typically extract a single field from this record, just like I've done now. And if that's the case, this method is way more expensive than it needs to be. And we can optimize our function by simply asking 2 additional questions, right? Do you want to include Saturdays or Sundays? And do you want to exclude the end date? That means we can create an alternative approach. So let's take a look at the code there as well. And I'll open the advanced editor once more, and I'll zoom in. So let's code. That's a positive sign. Let's dissect this as well. So this function takes 2 parameters, both of which are optional. Optional include Saturday, Sunday as logical, and an optional exclude end date as logical as well. Now, the return value for this function is a function. And after the goes to sign, we see that another function is being initialized. So that function looks familiar to the one that we've seen before, right? It takes 3 parameters: the start date, the end date, and a list with dates to exclude. And within the function body, we see, again, a conditional statement. But we also find a let expression within the else clause. So let's take a look. So the condition itself, so the if clause, it doesn't change. We're still looking to see if we have values for both the from date to the to date. And when that's not the case, I can simply return a null, right? No record, nothing fancy, just simply a null. Else, if we have values for both those dates, we can perform a calculation. And we can take the inputs from the parent function to provide some additional guidance for the function body that we're working on right now. So here we see add end date. That will equal 1 by default, right? We're setting the default to false, meaning that it will result in a 1. And the same goes for add weekend. We are also determining that we are also providing a default value of false, means that this will return a 5. That means that we'll be filtering out Saturday, which, if you start counting from 0, will be the 5th day, and Sunday, if you input that here, like if you're testing it against the day of the week number. So with this logic in place, let me touch on the double question mark before I forget. So we see the double question mark here, and we've seen it already above. And the double question mark is the coalesce operator, right? Here it's used, so in this section that I've highlighted, it's used to protect my calculation. What it does is it sees if the value to the left is a null, and if it is a null, it will return the value to the right. So in this case, if list dates to exclude, which is optional, is omitted, then a null will be used instead, meaning that the coalesce operator will detect that null and will provide the empty list to the right of it. Now, it's protecting my function because list distinct, of course, expects a list type. Now, a null is not a list, and therefore it would fail. But providing an empty list, that will solve the problem and prevent an error from occurring. All right, let's see. Let's invoke this as well, right? So we have a function that returns a function, and I'm just going to hit invoke, and we'll see what happens. We have an invoked function here, and I'll drag it all the way up. Let's rename this. Let's call it closure. There we go. Awesome. So I didn't provide any information to this function. And it's not required, right? Because both those parameters that we specified were optional. Meaning that when both are emitting, this function will always exclude days in the weekend, and it will always include the end date. Let's see that in action. Let me copy that bit of syntax here. And make some space. Add a new column. There we go, custom column. Call our function. Provide a set of parameters to it. And there we go. Awesome. So because of those default settings, excluding the weekends, and of course, including the end date, we get exactly the same outcome that we see right here. Now, if we didn't provide a list with holidays to exclude, if we omitted that, then of course we would get the date difference, including the end date, without Saturday and Sunday, but no dates to exclude, right? So going to press Control-Alt-A. That will change that into a comment, and I'll hit that check mark, and you can see that the outcome now matches the outcome from this expression right here. And of course, if we wanted to exclude the end date or even weekends, right, there's no button for us to push to achieve that. That's because we designed this function with a specific purpose, right? To always include, to always exclude the weekends and to always include the end date. So the only way to achieve that would be to adapt, to change the configuration of our function by setting the exclude weekends, for example, to true. That needs an R there, doesn't it? There we go. Let's take another look. Move that to the side. And there we go. So we've now included the weekends. So we're matching that the initial outcome that we see here as well. So basically what we did is we created a function that we can configure for a specific purpose. So let's go over what we discovered now. So lists are created with those curly brackets. Records are created with square brackets. The record expression can be used to calculate multiple column values in a single go. And the coalesce operator, that's a double question mark, and that helps to deal with optional parameters and null values. And a function value is just like any other value in M. You can create a function that returns a function. That's no problem at all. And it can be helpful to create something that you can configure for a specific purpose. All right. Any questions on this?
I see that Tom has his hand raised. If you want to ask something, feel free to do so. Tom? Lowered his hand? I'm not sure. You need to unmute.
While we wait for Tom, Aurora says to Melissa that one function is to give you all the answers. That's 100%. You always raise the bar. so that one was a big hit.
Yeah.
Awesome. Yeah. Well, there's so much you can do, right? You can create whatever you need. You have total freedom. So yeah.
Oh, Tom says oops.
Tom says oops.
Yeah. Probably
That's
he
no question.
wanted to clap. Yeah, probably he wanted to react instead of raise his hand. I do that mistake all the time because we see the little hand there, and I say, "Oh, it's probably
awesome.
what happened."
So,
thank you.
Yeah, if there are no other questions, we'll dissect another function.
Sure. Let's do that.
All right. There we go. So let's take a look at this query, and I'll move that to the side. All right. So the third group of our functions designed to be applied to a table, a list, or record, right? That group represents all of those powerful functions that operate on the entire structured value. Often that requires knowledge of how to transform and manipulate those structures as well. So I've selected the source step in this query so we can examine a common issue. And that's the scan row limit that exists for certain transformations. Right? Many users are surprised to learn that there is a limit to what's detected by the M engine, but it's there for performance reasons. So while I understand that it's there, the lack of communications or communication to a user, that is something that I often experience as being problematic. So for a split column operation, for example, the scan row limit is fixed to the top 200 rows in your query. So I've created this sample dataset, and if I scroll down, all the way down, there we go, we see on line 201, we have 1, 2, 3 values, and on line 202, we have 4 values within this column. So let's just try to split this column and see what happens. So on the Home tab, I'll press Split Column by Delimiter, Insert, There we go. And under advanced, I can see that the number of columns to split into is 2 and not 4. That means that I'm actually risking to lose data, right? And there's no indication, there's nothing here in this dialog is warning me that I'm at risk of losing data. So although there are low-code workarounds for this issue, I wanted to share a coded solution as well. So this ensures that you won't encounter unexpected data loss. Let's cancel this out. Again, this would be the split column action by default. So it separates, or it detected 2 columns to split into, so I'm actually losing data. And this is what the custom function does. It extracts everything. Let's now find out how it works. There we go. I'll move to the advanced editor. I'll open that up and I'll zoom in. There we go. So this function takes 3 parameters. First, because it is being applied to the entire query, it expects an input as a table, right? Next, we want a field name for the column that we want to split. And finally, of course, we want to be able to specify a delimiter as well. Now, that delimiter is optional, and it will default to a comma. So I've added some comments here in the code to help you understand what's going on. So the first step is converting our input table to a list of records. And you find that here on line 7. So here we're taking the table that we're providing to this function, and we're splitting it up into a list of records. Next, we're providing a delimiter to our splitter function. And again, we see that coalesce operator. We've specified the delimiter as optional, meaning that it can return a null. And when we get a null, we will just use the comma instead. So the splitter then is applied to the record field that has the field name that we wanted to split, right? And the result of that will be a list of values. Now we have that list of values. We are converting that back into a table. So we're creating a table from rows. So the result of that transformation will be a table with anonymous column names like column 1, column 2, and so on. So the next thing that I'm going to do is I'm going to rename those column names, right? I'll insert the original field name, and I'll keep the digits of that column 1, column 2, column 3, and so on. Right now, I'm combining those two together. So then I have a table, but I have a table with only the new values. I need to retain the data that's already there. So what I'm doing next is I'm using table first to convert everything back to a record again, and then I'm removing the field that we've split from the record that we had to begin with, and I'm combining the two using the ampersand. So now I have a new record which contains the original fields minus the field that we wanted to split and the new fields that we just created. Of course, everything in Power Query revolves around tables, so we're generating a table again from that new record that we just created. That, of course, when that transformation is applied to all of the rows in my table, I have one giant list with tables. And table.combine will then combine them to yield a single table as output. Now, there were a lot of value transformations in this routine that I just talked you through, right? And if you had trouble visualizing what that looks like, don't worry. So let's take a look at the inner workings of this function. So here are the inner workings. There we go. So the first thing that we did is we configured a splitter function that will be applied to our text column, right? And that yields a list. And here we see what that list looks like for row 201 from the table, or actually row 202. So these values will be generated by applying that transformation, by applying that splitting operation, right? Next, we're taking that list of values and we're transforming it into a one-row table. And that looks like this. So here you see those anonymous column names, column 1, column 2, column 3, and so on. Now, we don't want that. We want those column names to reflect the field name of the field that we wanted to split. So we're renaming those, inserting that field name, and keeping the digits from those anonymous column names. Next, we want to combine this new value that we just created to the record that we had to begin with. So here's our record merge. We're bringing all of that data together. Final step is to turn this into a table again. And when we do that transformation for all of the rows in our table, you get one huge list with a lot of tables. All that's left to do is combine them, and that will yield one huge table again. So this now is the answer, right? We have everything. There's no data. No data has been lost in this transformation. So that is basically what I wanted to show you on this one. It just, let me see, whether I invoke it here. You just call the function, input the table. We inputted the text column, so that was the field that we wanted to split. We can look in the source, that was this column. Once we invoked that function, we got the correct answer. Our table was split, or that value was split into 4 additional columns. Awesome. So that's what I wanted to go over and cover and talk to you about today. Some final notes. I've included comments in other queries, in the other queries that you see in this file. I know that we didn't get to explore them together, but I hope they will help you understand what's going on. And as I said, feel free to reach out on LinkedIn if you have any questions on that. I hope you've discussed or you enjoyed dissecting some of these custom functions with me. In general, custom functions are very, very useful in standardizing logic, ensuring a predictable outcome, and accelerating query development. So there's a lot that you can consider when designing custom function, but I think the most important thing is just to get started. Start building functions and keep it simple. Use the UI to create as much of the syntax as possible, right? If that helps you, and move on from there. And keep in mind that this session was just meant to inspire you and give you an idea of what's possible. I'll stop myself here, or we'll be here all night, or at least I will. Any questions?
Yes.
Thank you, Melissa.
We have Gaetan Mormont asked, is the 200 limitation the same for all M functions, or is it specific to the split column function?
Nope. You see the 200 row limit as well for detect data types. That has the same row limit. There are other transformations that I've noticed act differently. I don't know them all by heart, but these are 2 that cause problems regularly. Yeah.
Okay. And then Jose asked, was the comma delimiter hard-coded when you put in the delimiter in the custom function?
It's hard-coded as default value. So you can provide a delimiter. So if I were to provide a delimiter here, right, I can totally do so. Let's do something that will prevent a split. Go with that. There we go.
And
no
then
split occurs.
And then Gaetan asked the second thing, or commented, the delimiter seems to be an optional parameter of the function, see line 2. So I think that was responding to someone's, but I don't know
the
whether
same
that was his
question.
own or somebody else's.
The very same question, yeah.
Exactly, yeah.
That's what I see for the moment. Oh, wait a minute.
And there's a comment there from Varsham.
Yeah, is that a question or is that a comment? I haven't read it yet.
Any best practices performance recommendations. For example, if I have a large complex function, then is it better to keep it as a single function versus breaking it down into multiple ones? I know the answer starts with usually it depends, but we would appreciate any observation suggestions from the M master.
Awesome. Well, no pressure at all.
No.
All right. So the first thing that I want to address, if you create a huge function, and it's easy to do that, right? Even with help from the user interface. If you take files from a folder, right, a function will automatically be generated for you, and that can contain a lot of logic as well. What I love to do, especially when troubleshooting code, is turn that let expression into a record, meaning that you can view all of the calculation and all of the intermediate results in one single overview, right? So return a record and you can troubleshoot that function. Performance-wise, it really shouldn't matter. It's just that it's maintenance, right? And ownership. If no one else can take care of that function or enhance it, then long-term usability is kind of becoming a problem, right? So I would probably more lean on that, keeping future ownership in mind, and decide if that function should be broken down into several smaller steps, or if it needs additional documentation or whatever you can add to it to make it transferable to someone else. I think that would definitely help. Performance-wise, it shouldn't be a problem.
Great.
As far as I see, that's it for the questions.
Yeah, and I hope you guys have taken the, let me see if I have the link here in case you have not put in your name for the giveaway. You have just an extra few seconds before we do the draw.
Oh, yeah. I did too.
Yeah. And let me check here. Are we about that? We have 19 people, 19 responses so far. Yeah, the first one does not count because it was me testing the form. We have another one, so there's more people joining. So let's give them a little bit of time to take the opportunity.
While we're doing that, we have people saying, great session, thank you. Wonderful session, thank you very much. Thanks, Melissa. This was awesome. I'm going to try out these functions. So it's,
that's wonderful. That's wonderful. Yeah, thanks so much for that feedback.
Quite positive feedback. So
what I found most interesting was your creativity, Melissa. A function that generates functions and that suitcase. And I mean, it just really helps us realize that there's more we can do, right? And sometimes I speak for myself. I end up getting stuck within the same type of options and not realizing it's just about sometimes being in a rush, trying to get the solution fast. But if we give ourselves time to be creative, there's so much more we can do. So thank you for that.
Yeah. Awesome.
We have a sneaking question here from Aurora asking, is there anything special about handling errors related to custom functions?
Is there anything special about it? No, there are considerations, of course, like you've seen me implement constructs to deal with null values that could cause problems or that could raise errors. And the question is, basically, do you want to handle every possible error within your function? Do you want to include error handling? Or is there a certain point where you think an error is a valuable return value as well, right? It's telling you something's wrong with your with the function, or at least the evaluation of the logic that you've provided. So the question is, where do you stop? And you could even do it differently and decide, well, if an error is raised, then I'll provide my own instructions on how to deal with an error. And that means that you have to know what that error is about, and you can provide more accurate feedback to a user as to how to solve it. Right. So it's like I said, there's so many considerations, and at some point you have to decide, where do you stop?
There's speaking of errors and handling errors with Power Query. One of the great sessions we had in this meetup group was a while ago. So if you are interested in learning how to handle errors in Power Query, a session by Christian Engel. Go to our YouTube channel and go back maybe a year or so, and it's a fabulous session there available that I recommend. I refer to it every now and then because there's so much information and so many great tricks there.
Yeah, and also
That
if
was a
you're
good
one
one.
of the lucky winners, chapter 12 also handles errors and debugging. So for the lucky
Great.
ones.
Yeah.
Tarek is asking, have you got any special advice for fresh learners? So for people just starting out learning Power Query and M-code.
People just starting out. I always, honestly, I'm absolutely. I love talking about the M language, but I am a huge fan of the Power Query user interface as well, right?
Yeah.
Definitely. I mean, it's awesome. The things that you can achieve with it without knowing anything about M at all is amazing, especially when you get a little bit creative. There's just so much that you can achieve. So definitely don't skip learning what the UI can do for you. It also helps in speeding up query development, right? It can generate the bulk of the M code. You don't have to write anything, maybe just a few things here or there, and you're on your way. So never skip that part. It's crucial. Next, I always say, I usually start my session by saying, look, here's the button that you need to press if you don't see the formula bar on your screen. I skipped it this time, but look at the M code that's generated. It will give you a sense of how the language flows and the vocabulary of that language, right? And that will help when you start when you become ready to do something with that language. And the first step will probably be making small modifications to the code. And then, well, if you run into an issue which you're not able to solve through the UI, yeah, then you'll have to look into coding. But there's so many roads in between to get there. Don't get me wrong, I will still promote M. I love M, but I have a soft spot in my heart for the UI as well. It's an awesome
Yeah,
tool.
that's the beauty. That's the beauty of Power Query, right? Is that it does give the user the power to do a lot without having to worry about coding. And at some point, we will run into challenges that there's no button available for that. There's also a lot of functions that exist in the M code, but they are not available. There's no specific button to use them in the user interface. So referring to the Microsoft documentation, looking for the M language reference and just searching for something that you may need, and looking through the titles, it's quite easy to go through the different sections. There's the table functions, there's the list functions, there's the dates function. So you can quickly try to find what you need, and then look through the explanation. Unfortunately, not all the functions have a lot of examples or are very very well documented, but most of them, it gives us at least the starting point, and then Googling and putting the things, all of that together can help us start to build something.
And
That
of
would be
course, the
my
definitive
input.
guide. It
Yes.
really is named well. It definitely is the definitive
Yeah,
guide
the other
to
day
Power
I
Query
even
M.
the other day I even posted about it. I was at work. I have a copy there. I had one of these challenges I could not solve with the user interface, and just by going to the index, I was able to quickly find what I needed to create custom. What was it? Can't remember. Something that very specific for that day that I needed to do, and with the help of the book, I was able to really just solve it without spending too much time. So it was great.
I'm guessing a custom replacer.
Yeah, custom replacer. It was the case. Yes.
So much fun.
Because I had multiple values that I wanted to replace in different columns, and I didn't want to go do a step for each one of the values.
Yeah.
So that was very helpful.
There's actually an example of that in this file as well. So.
Okay, great.
Nice.
There you go, teaser.
Yeah. So stay tuned for an email that will come your way in a couple of days, and you will have access to the exercise file. And I think we are ready now for this draw, right? We have 26 submissions. So Melissa, you can choose any 3 numbers starting from 2, including 2, up to 26, including 26. Pick 3 numbers, and I highlight them here, and then I will show who the winners are.
Number 13. Lucky number 13.
The lucky number, lucky submitter of 13. Okay, another 2 numbers.
So for me it's the 25th. So 25.
25th. 25.
Oh, you're tomorrow already.
Okay, and we need another one.
Another one. There you go. Let's. What will number 2? Someone's got to be number 2.
Yes, it was the fastest person
awesome.
submitting today. So that is a fair choice, I would say. Okay, so I'm going to share my screen, and you will see the winners there. So number 2 is Jeremy Nathan. Is Jeremy around? Let us know in the chat.
Yes.
Jeremy is there. There you go. Congratulations.
Congrats.
And then we have Ahmed Ryan Jendi Korayem. I hope I'm saying close enough to the correct spelling.
There he is. Congratulations.
Yes.
Awesome.
Thank you. And we have Tom Mangos who just submitted in the last few. And is Tom Mangos there? Yes. Oh no. Grania is saying Tom Mangos. Tom, we need your yes.
I see it, Tom.
Yes.
Yay.
Yep.
He's
what
there.
Is it? Is it?
Yep. He says
there
yep.
he is.
Okay.
Awesome.
Great. So these 3 people will soon receive an email from the publisher with access to your copy. So congratulations. And thank you so much, Melissa, for getting these giveaways available, and most of all for your presentation today.
It was my pleasure.
It was fantastic. Really,
awesome.
really, really good.
Yeah. fabulous presentation. Thank you so much.
Thank you all so
And
much.
that's it. If there
Yep.
are not any further questions, I will stop the recording. And we can say goodbye. Enjoy your summer, everyone. We will be back in September.
Yes. And Melissa, enjoy your sleep before you have to get up in just a few hours to work.